polynomials or real numbers and polynomials over or polynomials rationals. So polynomials are polynomials are means coefficients are real numbers, right? So it is denoted by Rx, right? So what is it? Set of all polynomials with real coefficients. So this we discuss. Now, what is the important observation? R is a subset of Rx. Is it true? Can I say this? Yes. Can I say that R is a subset of Rx? For example, if I take fx is equal to 5, is it a polynomial? If fx is equal to constant or 5, is it a polynomial?
Yes.
Yes.
Right.
Yes, sir.
So this is a polynomial and it is in Rx. That means for every alpha belongs to R, alpha is a polynomial, is a constant polynomial. Right. So every constant number is also a polynomial. Therefore, for every alpha belongs to R, alpha is a member of Rx. That means R is a subset of set of polynomials. That is clear. Now, second thing, can I say that Z is a subset of Zx? Right? Can I say that Q is a subset of Qx? Yes. Is it true? Whatever I have written in the last expression, is it correct? Is it true?
Yes, sir.
Yes. Because if coefficients are integers, right? So if Px is equal to an x raised to n plus a1x plus a0, if it is in zx, right? That means all coefficients are integers. All coefficients are integers. Then can I say that keep Px is in Qx, right? Because all integers are rational numbers. Therefore, I can certainly say that it is also in Qx, also it is in Rx or in Cx. Therefore, this order is true. Zx subset of Qx is subset of Rx. Now, can I say that Zx is same as Qx? Yes. Is Zx same as Qx?
No.
No. In
No,
fact,
sir.
so not true, because if you look at Zx, it is a proper subset. Proper subset means if you look at polynomial Px is equal to 3 by 2 x square plus 5 by 7 x plus 9 by 6. So this is in Qx because coefficients are rationals. But Px is not in Zx. Right, so every polynomial with integer coefficient is in Qx, but not opposite other way. Reverse way is not possible. Fine. So also we discuss if Px is equal to an x raised to n and so on, a1 x plus a0, and qx is equal to bm x raised to m plus b1 x plus b0, then we know how to add px plus qx, right? So we'll add the term wise addition, constant added with a constant term of x added with, know how to add two polynomials, right? So we also discussed that so if px is equal to a n x raised to n and so on, a1x plus a0 and an is not equal to 0, then degree of px is equal to n, because highest degree term, if its coefficient is non-zero, then that is degree of polynomial. So if an is 1, then polynomial is called as, so an is called as leading
Sir,
coefficient. Yes.
sir, can you please increase the volume?
Okay, is it clear now?
Yes, sir.
Okay. So an not equal to 0, then an is called as leading coefficient. Leading coefficient. Coefficient of highest degree term. If n is equal to 1, then polynomial is called as,
Monic polynomial.
right, monic polynomial. So monic polynomial. So we also saw zero polynomial. That means if all coefficients are 0, then f of x is equal to 0. So all coefficients are 0. Right. So now we'll see how to multiply two polynomials. So in general, as I said yesterday, we can look at polynomial as a vector, and like vector, we can add two polynomials, but multiplication is something different. Right. So
Sir,
yes,
so these vectors are in n-dimensional space.
it depends. Okay, let me define one more thing. Right now, don't think about vectors, because vectors is a something different kind of thing. But anyway, I will tell you one more thing. Let Pn, this is capital Pn, denote the set of all polynomials of degree less than or equal to n. Means all polynomials whose degree is less than or equal to n. For example, what is P2 or P1? Let us consider P1. Polynomials of degree less equal. Now, can you understand what kind of set is P2? So, it is set of all such polynomials ax plus b over R, for example, you can say. So, all polynomials whose degree is less than or equal to 1. That means all polynomials are of this type. Then, do you understand set P1? Is it clear? Yes. For example, fx is equal to 2x plus 3. Is it a member of P1?
Yes.
Right. If I look at gx is
Yes.
equal to Gx is equal to 3. Is it a member of P1?
Yes. Yes.
Yes.
Yes.
Because it is 3 plus 0 times x. Right? It is polynomials. All constants are there, and at most degree 1 terms are there, not degree 2 term. Or if you look at hx is equal to 3x square plus 5x plus 7. So this is not in P1 because degree of this polynomial is greater than 1. So P1 is a set of all polynomials whose degree is less than or equal to 1. Right. So if you look at P1, which is ax plus b, a and b are constants, then this element, if fx is equal to ax plus b, this element I can identify with a comma b as a vector. Right, I can identify this as a vector in R2. And how to identify, that is a different thing. But as I said, you can look at it as a vector, means in sense what? Because x has no role as such, because the role of x is just a is a coefficient of x, means is this term coefficient of x and b is constant term. That is the role of x. Therefore, if I write g like or vector v is equal to 2 comma 3, then this corresponds to which polynomial? 2x plus 3. If you identify polynomial with a comma b vector, or 2 comma 3 vector can be identified with polynomial 2x plus 3. Right. So another way, if you look at polynomial gx is equal to 1, then what is the corresponding vector you can identify with?
0, 1.
Right. So if I am identifying x plus b with this, then I should identify this with 0, what it is actually, uh, 0 comma 1, right? So in this way you can identify polynomials of degree less equal 1 with vectors in R2. That kind of identification is there, but there is a, so to study such kind of identification or vectors and all the properties of vectors, so polynomials can be treated as a vectors, and how to deal with such vectors. And there is a course in SYBSc which is called as linear algebra, right? So that you will study in SYBSc mathematics, linear algebra. You can identify many objects as a vectors, and you can treat those objects as a vectors. You can identify matrices as a vectors. You can identify polynomials as a vectors. You can identify functions as a vectors. Right. Ultimately, what is the purpose of learning mathematics is to solve the real life problems. And in real life, you are not dealing with x and y, or you are not dealing with only numbers. You have to deal with many objects which are there in real life, and those objects could be anything. And therefore, you have to develop the analogy, how to treat those objects as with the concepts which you already learned in mathematics. Right. That is the way. But anyway, right now we are not very much interested in this kind of things, vectors and all this. We are interested only in properties of polynomials. Correct? Okay, so okay, is it clear? Please keep your mic off. Anaga, please keep your mic off. Okay, so now you want to see the multiplication. So two polynomials. So let Px is equal to an x raised to n plus an minus 1 x raised to n minus 1, a1x plus a0, qx is equal to bm x raised to m plus bm minus 1 x raised to m minus 1, plus b1x plus b0. And how do you multiply polynomials, binomials, polynomials? Right, what is the meaning of multiplication of polynomials? So px into qx is, what is px? It is c m plus n x raised to n plus 1 plus c m plus n minus 1 x raised to m plus n minus 1. So I am decreasing degree of terms, so c1x plus c0, where what is cm plus n? What is cm plus n? For example, look at this. Px is equal to ax plus b and qx is equal to uh, uh, qx is equal to r x square plus sx plus t. How will you multiply px and qx in this case? How will you multiply px into qx, which will be ax plus b multiplied with rx square plus sx plus t? And how will you multiply this? Arx square plus, what is next? X
A
cube. Arx cube, a into r x cube, then as plus, so what are the
X cube.
square terms? And b r x square, right? What are the constant term, degree 1 terms? at
BSX.
at plus bs. Is there any more term which is degree 1 term? And what is the constant term? bt. So this is how we multiply. That means, what is the highest degree coefficient? ar. That means highest degree coefficient of p and highest degree coefficient of q. That is what it is. So what is here in general? What is px into qx? If p and q are these polynomials am and bm. So cm plus n is an into bm, correct? What is cm plus n minus 1? Do you understand what is it? Or if you go back, what is a constant term c0 in multiplication, in product? What is a constant term? What is constant term?
A0 B0.
A0 into B0.
A0 into B0. But what is Cm plus n minus 1? You just look at P and Q, and what is the Cm plus n? M plus n minus 1 degree term. What is it? An Bm minus 1 plus An minus 1 Bm. Am I right? Correct. So highest degree term is obtained is obtained if you multiply highest degree terms of two polynomials. So in that way coefficients are this. So actually, what are the general term ak? What is the general term? Ak, not ak, ck. What is the general term ck? What is c0, c2, c1, c2, c3? So what is the general term? So general term is ak b0 plus ak minus 1 b1 plus ak minus 2 b2 and so on, a0 bk. This is a kth term, and whichever term you want you can obtain by this formula, or I can write it in short as a k minus j bj. J is from 0 to k, right? In short I write this. For example, what is c0? What is c0? What is c0 with this formula? What is C0 with this formula? Actually K is 0, so there is only one term, A0, B0. What is C1 with this formula? What is C1? A1 B0 plus A0 B1. Am I right? And what is the important observation from this formula? If you look at suffixes, sum of suffixes is K, right? K minus J plus J. What is the sum of suffixes? K. So AK B0, AK minus B1, and so on. So that gives us the kth coefficient of product, kth coefficient in product. So with this formula, can you tell me what is C2 in the product?
8B0.
A1, B1, A0, B2. Correct? In this way, what is last coefficient? What is the most uh, highest degree coefficient, or what is the last coefficient? Cm plus n. And what is it? What is it? Am plus n b0 plus am plus n minus 1 b1 plus am plus n minus 2 b2, and so on. What is the last term? A0 bm plus n. And in this process, some bn's are 0, some bk's are 0, and some ak's are 0. And so ultimately, what you will get, so remember here, m plus n is greater than m as well as n because it is a sum of these two numbers. Am I right? M plus n is greater than both m and n. Is it correct?
Yes.
And therefore, b m plus 1, b m plus 2, and so on, b m plus n are all 0. Is it correct? A n plus 1, a n plus 2, a m plus n. These coefficients are 0. Why? Why these coefficients are 0?
Because our polynomial is degree of n.
So degree of qx is m, and therefore higher order. So if you look at our polynomial q, so degree of q is m. So bm is non-zero, but what is the next degree term? Bm plus 1 x raised to m plus 1, but next coefficients are 0. So the higher coefficient bm plus 1, bm plus 2 up to bm plus n, all coefficients are 0. Degree of n px is n, so n is non-zero, and there is no higher degree term, means all other coefficients we can say that they are 0. So highest degree terms are 0, and therefore if you look at the expression for Cm plus n, what ultimately remains? What ultimately remains? So Am plus n is 0, Am plus n minus 1 is 0, till what? A M B A N B M, and then all remaining terms. So what is the previous to this? What is the previous to this term A N B M? What is the previous term? Do you understand what is the previous term to be A N B M? A N plus 1 B
bm m minus.
minus B M minus 1. Now, you observe all these terms before this term. What is the speciality of all these terms? Right? And what is the term after this? What is the term after this? What is the next term? What is immediately next term? Do you observe?
an minus 1 bm plus.
B M plus 1. An minus 1. Okay, let me write it clearly so that. So An minus 1 Bm plus 1. Correct. So immediately next term is an minus 1 bm plus 1. And look at all terms after this onwards. What is the speciality? What happens with this term? Right, each term contains a coefficient an whose suffix is greater than n. Suffix is greater than an plus 1, an plus 2, an plus 3 up to an plus m. And therefore all such coefficients are 0. So therefore the expression underlined by green line is 0. Is it correct?
Yes.
This is 0, this is 0, this is 0, and this is 0. Up to this, each an plus 1, an plus 2, all are 0. Therefore, this expression by underlined by green color is 0. What after this? An minus 1, bm plus 1.